Hello everyone, welcome to Vedantu Malayalam channel. I'm Sana Khan, your maths master teacher, and I am back again with lecture number 2 of trigonometric functions. So how are you guys doing? Hope yesterday's class was super clear to you guys, where we basically learned the basics of trigonometry, that is the angles of trigonometry. How do we measure them in degree and radians, and how do we convert them into each other? Basically, that's important because now today onwards you are going to learn about trigonometric functions, which are all about the angles of right angle triangle, right? So in this chapter we will be learning about the angle measurements, the trigonometric functions, their domain and range, and their sign rule, and we will also learn about the different laws and identities of trigonometry, specifically for their sum and difference of two angles. Okay, so in yesterday's lecture we have already learned about angles. In today's class we will be learning about trigonometric functions. So are you guys ready to start? Okay, so let's quickly start and learn about the trigonometric function. So in class 10th, we have learned about trigonometric ratios. Now, what are those trigonometric ratios? Can you guys just recall them? So, can you remember what is sine, cos, tan for a triangle? Or how do we calculate their values? How are they related to a triangle? Do you remember that? Well, basically, there is a Hindi line which says that Pandit Badri Prasad Hare Hare Bol. Now, this mantra is actually used in mathematics for trigonometric function value calculation. How come? Well, we know for every right angled triangle, the side which is opposite to the right angle is called as hypotenuse. Then the vertical side is called as perpendicular, and the horizontal side is called as the base of the triangle, right? So P for perpendicular, H for hypotenuse, B for base. So here, from here we are basically deriving the formula for the different trigonometric functions. For example, if this angle is theta, then sine theta is P upon H. Okay. What is P upon H? Perpendicular upon hypotenuse. Okay. Similarly, cos theta is B upon H, base upon hypotenuse, and tan theta is nothing but perpendicular upon base, P by B, that is perpendicular upon base. These are the basic trigonometric functions and ratios that we use. Alright, now there are three more trigonometric functions which are related to them. First is cosec theta or cosec x. It is basically 1 upon sin x. Secant x is 1 upon cos x. Tan x is nothing but sin upon cos, and cot is nothing but cos upon sin, which is also 1 upon tan x. Okay. So these are the 6 trigonometric functions that we are going to learn in this chapter one by one. We will see their domain values, their range values. We will learn about their sign rule in different quadrants and how do we find value of these functions. Alright. Now, is my video buffering? Let me just see. I guess it's fine. Okay. It's not buffering. Yeah. Now, there are some trigonometric identities which you have learned in class 10th, which we will be using in this chapter as well. Number 1, sine square x plus cos square x is always 1. 1 plus tan square x is secant square x, and 1 plus cot square x is cosec square x. Okay, these are the three rules which we have already learned in class 10. We will be also using them in this chapter. Now moving on to the table of trigonometric ratios. To find, basically we should know the known angle values so that we can derive other angle values using them. Okay, so first comes 0 degree, then let me change the color. Pi by 6 is 30 degree, pi by 4 is 45 degree, pi by 3 is 60 degree, pi by 2 is 90 degree, pi is 180 degree, 3 pi by 2 is 270 degree, and 2 pi is 360 degree. Okay, now these are the corresponding values given over here. Okay, so what corresponding values? Sine 0 degree is 0. Sine 30 degree is 1 by 2. Sine 45 degree is 1 by root 2. So this table basically tells you the value of these angles, sine, cos and tan. Now if you want cosec 0 degree, what is it? Cosec 0 degree will be 1 upon 0, that is undefined. Cosec 30 degree will be reciprocal of 1 by 2, 2. Cosec 45 degree will be root 2. Cosec 60 degree will be 2 by root 3, and so on. So basically you will be finding out the reciprocal of these values to get your original function values. Alright. So these were the trigonometric functions and their values which correspond to the given known angle values. Okay. Now moving on to the sine rule of trigonometric functions. Now the sine rule is pretty easy to remember if you remember one single line. Add sugar to your coffee, or you can say all silver tea cups. You can comment and tell me that what statement is used in your school to remember the sine rule of trigonometric functions. Okay, so in my school time we used to remember all silver tea cups. Now what does that mean? All silver tea cups basically denotes in the first quadrant all the trigonometric functions are positive. In the second quadrant, S for silver, S for sine. Sine is positive, all the others are negative. So if sine is positive, obviously cosec will also be positive, right? In the third quadrant, T for tan. Tan and cot are positive. In the fourth quadrant, C for cos. Cos and secant x are always positive, the remaining are negative. So it is very too easy to remember first, second, third, fourth, all silver tea cups, add sugar to coffee. If you remember this line, you will be able to remember the sine rule also, right? So in the first quadrant, we have all silver tea cups. So all are positive. You see, plus, 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 plus. All the functions have positive sign. In the second quadrant, only sine and cosec. In the third quadrant, only tan and cot. In the fourth quadrant, only cos and sec are positive. The remaining are negative in that particular quadrant. So I am telling you basically the sign of the function according to the input value. Now can anyone tell me what do we understand by first quadrant, second quadrant, third quadrant, fourth quadrant? Basically, first quadrant means x and y are positive. Second quadrant, x and y are negative and positive. Third quadrant, x and y are negative. Fourth quadrant, x is positive but y is negative. It also basically means first quadrant denotes 0 degree to 90 degree. Second quadrants denote 90 to 180. Third is 180 to 270. And fourth is 270 to 360 degree. Hope you all know this, right? So if you look at this diagram also, this basically denotes 0 degree or 360 degree. Here it is 90 degree, here it is 180 degree, here it is 360 degree, and here it is 270 degree. Okay. Now, let's learn about the domain and range of trigonometric functions. Now, domain means the permissible inputs, range means the permissible outputs. Now, what do we understand by permissible? Allowed. Allowed inputs and allowed outputs for every trigonometric function. Let's learn about them. Now, first we have sine function. Now, how does the graph of sine function look like? The graph of sine function looks like this, right? It basically oscillates between 1 and -1. So, the graph of sine clearly denotes that all the real numbers are there in the domain of sine function. So, domain of sine function is basically all the integer values. And what is the range of sine function? The range of sine function is only between -1 to +1. Sine function never goes beyond +1, never goes beyond -1. Okay. So, it is always there between +1 and -1. So, the range is +1, -1 to 1. Okay. Next is, it always repeats after 2 pi angle. What does that mean? So, if you observe the graph carefully here, between 0, okay, 0 to 2 pi, your graph looks like this. It looks like this. Now, similarly, between -2 pi to 0, again your graph looks like this. So basically the graph of sine function repeats after every 2 pi. What does that mean? That if sine 0 is 0, then sine 0 plus 2 pi will also be 0. So it will repeat same value after every 2 pi angle. Okay. Now let's look at the graph of cos x. Cos x once again oscillates between 1 and -1. So the domain is set of all the integers. You can give any integer as the input, but range is only between -1 to 1. It never goes beyond -1 or above 1. Okay. It also repeats after every 2 pi. If you observe carefully, the graph looks same to same after every 2 pi angle. So between 0 to 2 pi, it looks like this. Where is my cursor? Yeah, it looks like this. Again, between -2 pi to 0, it again looks like this. So every time your graph is going to repeat the value. So once again, if let's say cos pi by 3, that is cos 60 degrees 1 by 2, then cos 2 pi plus pi by 3 will also be 1 by 2. So after every 2 pi angle, cos will repeat. Okay. Next comes cosec function. Now what is cosec function? Cosec function is 1 upon sine function, right? Now, whenever your sine function is 0, cosec will be undefined, right? So, the domain of cosec function includes all the real numbers except when sine is 0. So, x should not be equal to n pi because sine n pi is 0. Therefore, cosec n pi is undefined. Why? Because 1 upon 0 is undefined. So cosec function will only be defined for inputs where sign is not 0. And what about the output? So if you observe the graph, it is an upward parabola. This upward parabola is basically starting from 1 and it is going above 1. So basically the output of cosec function is always greater than 1 or less than -1. It is never between 1 and -1. Okay, it's opposite of sine function. Similarly, secant function is reciprocal of cos function. Now cos function is 0 when we have a multiple of pi by 2, 90-degree multiple. So therefore, for every pi by 2, 3 pi by 2 minus pi by 2, it will be undefined. And the range of the function, once again, if you look, it is always greater than 1 and less than -1. Okay. And it also repeats after every 2 pi degree. Radian, sorry, not degree. Next is tan theta and cot theta graph. Now tan theta is basically sine upon cos. Again, cos 0 means tan is undefined. So it is undefined only where cos is 0. All the other real numbers are allowed in the domain. And the range is set of all the real number. Now interesting thing is, if you look at the output of the function, the graph is going from infinity to infinity. Like all the real numbers can come in the output. Interesting, right? One more thing is interesting. Tan theta repeats after pi radian. And similarly, cot also repeats after pi radian. Cot will be 0 when sine is, cot will be undefined when sine is 0. And the range is set of all real numbers. Okay. Now let's do some interesting questions based on whatever we have learned till now. First one, if cos x is -3 by 5, where x lies in the third quadrant. Now what happens in the third quadrant? In the third quadrant, all silver teacups. So tan or cot will be positive. Okay. So first of all, cos x is -3 by 5. This implies that secant x will be -5 by 3 because secant is inverse of cos. Remember? Now, 1 plus sine square x is cos square x. So, sine square x is -3 by 5 whole square minus 1. So, this is 9 by 25 minus 1. Oh, sorry. My bad. 1, we want sine value, right? It is actually opposite. The formula is cos square x plus sine square x is 1. So sine square x will be 1 minus -3 by 5 whole square. So it is 1 minus 9 by 25. So 25 minus 9 is 16 by 25. Therefore, sin x is square root of 16 upon 25. So sin x is plus minus 4 by 5. But we know that only tan and cot are positive. This implies that sin x is -4 upon 5. It cannot be positive. Okay. Similarly, till now we have seen cos is -3 by 5. Sine is -4 by 5. So we know that secant of x is 1 upon cos x. So it will be -5 by 3. Cosec x is 1 upon sin x. So it will be -5 by 4. Tan x is sin upon cos. Now, what is the sine value? Minus 4 by 5 divided by minus 3 by 5. So 5 cancel, it will be 4 by 3. And lastly, cot x is 1 upon tan x. So it will be 3 by 4. So like this we have found out sine, cos, secant, cosec x, tan x, cot x. All the functions. Alright guys. Next question. Find the value of cos minus 1710 degree. I don't know the value of cos 1000 degree. How will I find it? Well, I know that after every 2 pi, cos repeats itself. Let me find out what is 2 pi into 4. It will be 8 pi. 8 pi is basically 8 into 180 degree. So it will be 800, 8, 8 is 64, carry over 6, 8 1 is 8, 9, 10, 11, 12, 13, 14, 1440. Not closer. Let me find out 2 pi into 5. It will be 10 pi and it will be 1800 degree. Now 1800 is much closer to 1700. So now basically cos minus 1710 degree can be written as cos 5 times of 2 pi plus minus 1710 degree. Why? Because cos repeats itself after every 2 pi radian, right? Now, we know that cos theta and cos 2 pi plus theta are one and the same thing. So, cos 1800 minus 1710 degree is how much? It is cos 90 degree. And how much is cos 90 degree? 0. So, this is your answer. Simple, right? Next question. Find the value of sine 31 pi by 3. Now, I can write sine 31 pi by 3. Can I write it as a multiple of 2 pi? Let's see. I can write this as sine 10 plus pi by 3. Because 3 tens are 30, 30 plus 1, 31 pi by 3. Now, sorry, 10 pi here. Now, this is basically sine 10 pi plus pi by 3 can be written as what? It can be written as 5 times of 2 pi plus pi by 3. Right? Now, we know that after every 2 pi, sine repeat itself. So, this is same as sine pi by 3. Now, how much is sine pi by 3? Sine 60 degree is how much? It is 1 upon root 2. That's your answer. Simple. Okay, next question. Okay, this question is now homework for you guys. Till now, whatever we have done, based on the concept, solve this question and comment the answer quickly. Okay, next question. Get ready for some practice time. Number 1. Find the value of other 5 trigonometric function if secant of x is 13 upon 5 and x lies in the 4th quadrant. 4th quadrant is all silver tea cups. That means cos and sec are positive. Remaining negative. First of all, secant of x is 13 upon 5. So, cos x is 5 upon 13. Now, we know that sine square x plus cos square x is 1. So, sine square x is 1 minus 5 by 13 whole square. So, this is 1 minus 25 by 169. This is 169 minus 25 upon 169. So, sine x is basically square root of 144 upon 169. Sine x will be minus 12 by 13. Why minus? Because only cos and sec are positive. Sine will be negative. Okay. Now, cosec will be 1 upon sine. Now sine is minus 12 by 13, so this will be minus 13 upon 12, reciprocal. Similarly, we have tan x. Tan x will be sine upon cos. Now sine is 12 by 13 and cos is 5 by 13. So we have minus 12 by 5. And lastly we have cot x is 1 upon tan x. So it will be minus 5 by 12. Now here we have all the values: cosec, tan, cot, sine, cos, secant x. All the other 5 trigonometric functions are here. Alright, next question. Find the value of trigonometric function tan 19 pi by 3. Can I break it as a multiple of pi? Because tan repeats after every pi. Now tan 19 pi by 3 will be tan 3 6 18. So I can write it as 6 pi plus pi by 3, right? 6 3 is 18 plus 1 19. So now tan repeats after every pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So this is equal to nothing but tan pi by 3. Now what is tan pi by 3? Tan pi by 3 is tan 60 degree, which is root 3. That's why you have to remember the formula and the values of all the trigonometric ratios. Okay. Next, what is cosec minus 1410 degree? Now we know that 4 pi is 4 into 180 degree is 8 4s 32, 2 carry over 3, 4 1 4, 5 6 7. No, we don't want 4 pi, we want 4 into 2 pi is 4 into 360 degree is basically 6 4 is 24, 4 carry over 2, 3 are 12, 13, 14, 1440 degree, right? Now we know that cosec minus 1410 degree can be written as cosec 4 times of 2 pi plus minus 1410 degree, because cosec repeats after every 2 pi. So we can add 2 pi, 4 pi, 6 pi, 5 pi, 8 pi, multiples of 2 pi. Okay. So this is basically cosec 1440 degree minus 1410 degree, which is cosec 30 degree. How much is cosec 30 degree? 2, because sine 30 degree is 1 by 2. So cos is 30 degrees 2. That's your answer. Okay. Next, find the value of sine minus 11 pi by 3. Now how can I write minus 11 pi by 3? Minus 11 pi by 3. Maybe I can write it as sine 4 pi minus pi by 3. Can I write it like this? 4 3 is 12, 12 minus 1 is 11, right? So I can write it as 4 pi minus pi by 3. Oops. Yeah. Or no, but this will become positive. And yeah. Now we know that after every 2 pi sine repeat itself, so it will become sine pi by 3. Now sine pi by 3 sine 60 degree, it is 1 upon root 2. That's your answer. Alright guys, so that's how we basically find out the value of trigonometric function. Today's lecture is complete. Now in the next lecture we are going to learn about how to find out basically the sum and difference of different trigonometric function. And because of that, today we learned how to find out the value of trigonometric function. Only then you can apply the laws and identities, right? So here's the cheat sheet for all of you. If you know sine and cos value, you can find out cos x, secant x, tan x, cot x function as well. This is the sine rule. Remember, all silver tea cups add sugar to coffee. So, all positive, sine and cosec positive, tan and cot positive, cos and sec positive, right? And this is the domain and range chart of every trigonometric function. Alright guys, in lecture number 3, Monday, we will learn about trigonometric functions of sum and differences of two angles. Alright. Now, quickly join our Telegram channel if you want notes of every chapter, assignment links and daily notifications. Also, if you are new on the channel, don't forget to subscribe for more videos of maths, physics, chemistry and biology of +1 and +2 lectures. That's all for the day, guys. Thank you so much for watching. Do leave your comment and share your feedback. Did you enjoy our lectures or not? Okay guys, see you on Monday with lecture number 3. Till then, take care, have fun. Bye bye. Bye guys.